Okay, everyone, let's take a look at number 6 in section 3.7. We're dealing with the chain rule here, right? We're going to use the chain rule to find the derivative. And what are we looking at here? This indicates, right, the d over dx indicates take the derivative with respect to x of something. I would like to maybe even put this, in a brackets or something to emphasize we're taking the derivative of this whole thing, right? So when we're talking about chain rule, we're talking about an inner and outer function, right? Like f of g of x. G is the inner function, f is the outer function. Do you see which is the inner and which is the outer here? The inner is g of x is x plus 5 divided by x minus 5, or we could say u is equal to x plus 5 divided by x minus 5. And then the outer function, f of x, is just x to the fifth power, or we can write y is what? U to the fifth power, right? So you've got u to the fifth power, where u is x plus 5 divided by x minus 5. So recall the chain rule. For a composition of functions, the derivative is what? The derivative of the outer function f, evaluate the inner, times the derivative of the inner. Okay, so I'm going to have to take the derivative of the outer function. And what's the derivative of u to the fifth? It's what? 5u to the fourth by the power rule. But then times what? The derivative of u with respect to x. And when I take the derivative of this, I'm going to end up using the quotient rule. So let's see how that looks. So the derivative of this stuff to the fifth power, again, the derivative of u to the fifth becomes 5u to the fourth, where u, right, is our inner function, times the derivative of that inner function. And so when I take the derivative here, I'm going to be doing the quotient rule. So recall the quotient rule, I take the derivative of the top. Derivative of x plus 5 is 1 over the bottom minus the top times the derivative of the bottom, which is 1. So I'm going to clean all over the bottom function squared. So I'm going to clean up the numerator. I get x minus 5. And be careful here, this becomes minus x minus 5. So the x minus x is gone. I have negative 5 minus 5. That's negative 10, which I can write this way. Or I can write it this way. And so here we have 5, which I'm going to write as 5 over 1, just to emphasize, because I'm going to write this in fraction form. And then x plus 5 over x minus 5 to the fourth, I can write as x plus 5 to the fourth divided by x minus 5 to the fourth. And then here's the derivative of that inner function we just calculated. So there's the 5, there's this part, and then the derivative by the quotient rule of the inner function. So this is our answer. Let's clean it up. Multiplying 5 times negative 10 gives me negative 50, x plus 5 to the fourth, and 1 times this. Notice what happens, x minus 5 to the fourth times x minus 5 squared. These are like bases, so I can add the exponents, and there I get the result. Again, I've got a negative divided by positive, so sometimes we'll bring this negative out. It's a negative result in terms of how we write the expression. Okay, so a little bit more involved here. Chain rule adds wrinkles into our problems, but that's the way we need to proceed. So hopefully this is helpful on this one.